Section 17, question 1. The diagram shows water lying in a length of roof guttering. The cross section of the guttering is a semicircle with diameter 10 centimetres. The water surface is 8 centimetres wide. Calculate the depth of water in the guttering. Invariably these questions are Pythagoras. So if we know that that's 10 centimetres across, we can say that the radius is definitely going to be 5. Now we also know that if we have this 8 here, that this length here is 4. Now the question is to find the depth here. Now we can see that if the radius is 5 here, then the radius is also 5 there. So really what we're looking to do is to find the length between here and here. Now we can see that, as previously stated, that's 4 centimetres. That's also the radius from the centre to the edge of the circle, just as it is here and here and here and here. So that's also 5 centimetres. This line that I'm kind of making a bit more bold then, I'm going to call that line A and use some Pythagoras to work out the length of A. So for the short side it's going to be subtract A squared equals 5 squared minus 4 squared. A squared is equal to 25 take away 16. A squared is equal to 9. A is the square root of 9. And that's 3. Now we know from here to here is the radius, and that's 5 centimetres. If this part is 3, which we just worked out from Pythagoras, then the depth would be equal to 5 take away 3, and that is 2 centimetres, and that's the end of the question. Section 17, example 2. ST, a vertical pole, 2 metres high, is situated at the corner of a rectangular garden, PQRS. RS is 8 metres long and QR is 12 metres long. Now it's a rectangular garden, we're looking at it in a kind of 3-dimensional context, but we would know then if it's rectangular that this angle here is a right angle. Question says the pole casts a shadow over the garden. The shadow reaches M, the midpoint of QR. Calculate the shaded angle TMS. Well, we're eventually going to get there by having information about this triangle. Now we've got information here which is that it's 2 metres, but we've got information we could find out. That's not enough to get the shaded angle, but we could find this side out here using a bit of Pythagoras. So I'm going to call that side B and use Pythagoras. This is 8. Now from Q to R that's 12 metres, which means MR would be half of that. It's the midpoint, and that's 6 metres, and I can apply a bit of Pythagoras. So B represents the hypotenuse in this right angle triangle, this one here. So B squared will be equal to x squared plus 6 squared. B squared is equal to 100, and B is equal to the square root of 100. B is equal to 10 metres. Now, I now know that that B is equal to 10 metres. I'm looking for the shaded angle. This is a SOHCAHTOA question, so it's right angled trig. So I would label 2 as the opposite. B, 10 metres, now acts as the adjacent for this right angle triangle with the shaded angle. So write down SOHCAHTOA. Tick off both sides that you've got. So you've got the opposite and you've got the adjacent. 2 ticks, you're going to use the tan ratio. So tan of the angle, so I'll just call the angle x just now. Tan of x is equal to opposite over adjacent, and that's 2 over 10. Now at that point it's just entering the stuff into the calculator. and I'm going to round this to 1 decimal place. And the final answer is 11.3 degrees. Section 17, question 3. A badge is made from a circle of radius 5 centimetres. Segments are taken off the top and bottom of the circle as shown. The straight edges are parallel. The badge measures 7 centimetres from the top to bottom. The top is 8 centimetres wide. Calculate the width of the base. So I think Pythagoras again is going to be looking to be involved with this one and creating a right angle triangle. Now, what I can do with this one is, if I split that 8 down the middle, this bit here would then be 4 centimetres. I know that that's a radius, so that's also 5. It's the radius definitely because it goes from the centre of the circle and it hits the curved edge of the circle, it hits the circle. So that's 5 and that's 4. If I call that C, I can apply a bit of Pythagoras for a shorter side. C squared will be equal to 5 squared minus 4 squared. C squared is equal to 25 take away 16. C squared is equal to 9. And C will be equal to the square root of 9, and that's 3. Now if that bit's 3 and the height of the badge is 7, I know for definite then that this bit here will be 4 centimetres. So again, I can apply a bit of Pythagoras again. This time I'm going to call this bit A. A squared is equal to 5 squared minus 4 squared. A squared is equal to 25 take away 16. I've been through this already. A squared is equal to 9 and square root of 9 is 3. Now I can see that the width of the bottom is actually going to be double that value. So the width will be given by, and I'll call that W, 2 lots of A, 2 lots of 3, and that's 6 centimetres. That's the end of the question. Section 17, question 4. A triangular paving slab has measurements as shown. So the hypotenuse is 110 centimetres, our two sides are 1960. Is the slab in the shape of a right angle triangle? This is basically a converse of Pythagoras question, which really just means that if Pythagoras works, you must have a right angle triangle. So let's have a go. So 110 squared, and let's see if that's equal to 90 squared plus 60 squared. So in the calculator, enter it in. So 12,100. 90 squared plus 60 squared is going to be 11,700. We can clearly see that Pythagoras didn't work, so put a line through the equal signs to say not equals. So at that point you would say LHS does not equal RHS, therefore triangle is not right angled. That's the end of the question.